Okay, today we're going to take a look at reactions and solutions, solving reactions and solution. Okay, the first question we have here says how many milliliters of 0.25 molar potassium hydroxide will react with 15 milliliters of 0.35 molar H2SO4. The equation for the reaction is 2 potassium hydroxide plus 1 mole of sulfuric acid yields potassium sulfate plus 2 moles of water. Alright, I'm going to show you how to solve these problems two different ways. The first way that I'm going to show you is just something that I've experienced over the years that seems to work with a lot of these types of problems. And the other way is what we would generally find in our textbooks in terms of solving these problems. Alright, so let's label the problem. So how many milliliters of 0.25 molar KOH? So this M1 would be my first volume that I'm getting, and this volume is associated with this base. So this is the volume of my base. And then this molarity is the first molarity that I'm approaching. So this is the molarity of my base. Will react with 15 milliliters of 0.35 molar H2SO4. So this here, 15 milliliters is the volume of my acid, and this 0.35 molar H2SO4 is the molarity of my acid. So to solve this problem, I use the dilution formula. But with using the dilution formula, I add a little bit to it. I add one more concept to it, which is I take into account the molar ratio that occurs in the chemical equation. So the formula will look like this. It would say the moles of the base times the molarity of the acid times the volume of the acid is going to be equal to the moles of the acid times the molarity of the base times the volume of the base. Volume of the base, that's a B. So if I do it this way, this XB is the moles of the base, which comes from 2, which is 2. So 2 potassium hydroxide is your base, and the moles of the H2SO4, which is 1. So in this particular instance, we want to solve for VB, which is this here. So simply what we would do is just say VB is equal to the moles of the base times the molarity of the acid times the volume of the acid divided by the moles of the acid times the molarity of the base. When we do that, we substitute back into the equation. XB as moles of the base is 2. Molarity of the acid in this instance here is 0.350. 0.0350 times the volume of the acid, which is 15 milliliters. Now this doesn't have to be converted to liters because we're going to ask for our answer in liters. So this is 15, and then we're going to have the moles of our acid, the Y of A, which is, this is a 1 here, which is going to be 1 times the molarity of our base, which in this instance here is 0.250. So this times 0.250. When we do this, do the calculation, our answer comes out to be 42 milliliters of KOH. Now, this is a simple way of doing this particular type of problem. This is not what your typical professor will teach you in class. So this is a little shortcut that works, and it works 99% of the time. But now I'm going to do it the way that it's taught in standard textbook. So let's take a quick look. It says, alright, the first thing we need to do is find, if we're doing it the other way, the first thing we're going to do is find the moles of H2SO4. Find the moles of H2SO4. So, in order to find the moles of H2SO4, we would simply multiply we know that molarity is equal to moles over liter. So we would just simply rearrange this equation and get liters times our molarity, which is going to give us our moles. In this instance, we're going to convert 15 milliliters to liters. So 15 milliliters is going to be equal to 0.015 liters. And then this number is going to be multiplied times our molarity. So times 0.350 moles of H2SO4. This here would give us 5.25 times 10 to the minus 3 moles of H2SO4. Alright, now that we found the moles of our H2SO4, we're going to find the moles of the base using the balanced chemical equation. So if I have 5.25 times 10 to minus 3 moles of H2SO4, for my balanced chemical equation, I know that for every 1 mole of H2SO4, I have 2 moles of potassium hydroxide. Moles of H2SO4 cancel out, and my answer is in moles of the base, which in this instance would be 1.05 times 10 to the negative 2 moles of KOH. Now that I know the number of moles of KOH, the next thing that I want to be able to do, excuse me, is use my equation for molarity, which says that for every, I want to use my equation for molarity, which is, I have molarity is equal to moles per liter. I want my answer to be in liter because we're asked to find the number of milliliters of potassium hydroxide. So I have liters is equal to moles over molarity, which I know my moles. My moles is 1.05 times 10 to the minus 2 moles. And I know my molarity. My molarity is 0.250, which is 0.250 moles. When I do this, My answer would be 0.042 liters, which if we convert this to milliliters, we get 42 milliliters. So this is the exact thing we got when we did the reaction the first time, using the moles of the acid time the molarity of the base time the volume of the base is equal to the moles of the base time the molarity of the acid times the volume of the acid. So it's the exact same thing that we had before, but this is the standard way that you would end up doing this problem.